We have in today a hot block. This thing is used to calibrate temperature sensors, usually in things like food industries where the accuracy of temperature is really important. It turns on and displays everything, but it doesn't heat up or cool down. So let's just take a look. So this is the temperature calibrator, also called a hot block. And you can see if we rig it up and turn on, this has already been partially opened by the customer first to just check some basics. We've got a temperature display, which is the ambient temperature in the room. You place your device for calibration testing in the hole here, and what should happen is if we select set and say set a temperature at almost 0, it should now cool down, and then this would change as it goes. Based on the current draw here, it's not doing anything because that should increase. If we also set and try the heat, it changes to heat here, and this changes by 20 milliamps, so very little difference, but either way something's not working. We have an analog out here which should read the voltage that matches the temperature, so we can see we have a readout of 1.205 volts, which I'm guessing would be 1 is the offset, 208 is approximately correct. If we just take our hot air and let's warm this up and see if the temperature changes, then we'll know if the sensor's actually working. There we go, that's now starting to rise. You can also see the voltage there is rising to match. So it does seem the sensor's working and the device in general, but the actual element that heats up and cools down isn't working. So the next step is to get inside this. And now we're inside. We can see probably the biggest capacitor I've ever seen, 22,000 microfarad. We've got some big transformers, lots of dirt, and there's the heating and cooling element. Now we can power this by 12 volt battery and not mains, which is what I'm going to do. The transformer and all of this is very much likely mains down to 12 volt DC, so I'm pretty sure that's okay. All the logic seems to be working correctly, so I'm not really fussed about that. I reckon the issue is going to be in this block. So the block should have a temperature sensor, which is probably this black and red wire here. I guess we can confirm that by removing the wires and seeing the temperature gauge go different or wrong. We've got a block here with thick wires, a block here with thick wires. So what's probably happening for the heating and cooling is a Peltier sensor. And they basically look like this. There's just a plate, and the point of a Peltier is, depending on which way you apply the voltage, it keeps one plate at a different temperature than the other. So you can use it to both heat and cool. They're not very efficient, but that's how they operate. So my guess will be we've got one or maybe two, I'm not sure what this one is, but the thick wires is going to lead me to think that these two pins here and maybe these two pins here are Peltier coolers. Let's just cover this so we don't short anything out. Rest that over. Turn on from 12 volt bench power. You can see we're drawing about 0.9 amps. So if we just set this to say cooling, now it says cool, and if we probe on say these two, we're getting -7 volts. So if that is a Peltier cooler, if we change this to heat and measure again, and we can see the polarity as inverted. So this is very much likely a Peltier cooler here. And removing this from the board, you can see that's practically set on fire. I think that part is the power input more than anything. And if we look on the side, there's 4 bolts here, which would probably be the bolts for a Peltier cooler. So I'm actually thinking this and this, both sides, are the Peltier coolers. We set the bench to 7 volts 3 amps and inject one way. You can see it's maxing out the bench, which is normal. Peltier coolers pull, tens of 20 of amps. Now let's just thermal camera this edge, and we can see there that it's slowly rising. So 24.1, 24.3. So if this is a Peltier cooler and working, if we now flip the polarity of these around, we should now observe a cooling effect. And there you go, 22, 21, So that's bringing the temperature down. So I'll just leave it for a few minutes and see if this does actually cool down. And you can see just after a couple of minutes, it's down to 18.7 and dropping, and there's a clear cold patch there. So this is definitely a Peltier, and it's definitely working. And the same for the other side. I've checked that works. So we might just be dealing with a really simple fact of this connector burning out and not making contact. So let's just check that. And this should come in, go to the middle pin, which it's not, and then to here. So you can see the middle pin is connected, but this isn't. And on the underside, they should both be joined here. So it's very just likely, well, it is likely, it is what's happening. This connector's just burnt out. So with that yellow wire simply soldered to the underside now, let's power on. And we've got no display, but we do have 3 amps, which is maxing out that power supply. That's probably to be expected because these Peltiers will need a lot of power. So let's jump to the larger bench. Now this thing can push 80 amps, so I've just limited it to 10 for now. We don't want to go crazy with the power draw. And let's turn on and monitor the current. There you go, boosted up to 10. It's powered on. So it's drawing the same 0.9 amps at the minute. Let's set it to cool. And now, there we go, pulling 8 amps. So let's inspect this with a thermal camera. Well, for a start, that temperature's flying down. So before we even get the thermal camera on, it looks like it's working. And there we can see that will be the Peltier warming up on the outside to pull the heat from the center of the core. So you might expect to see that plate cold, but you'll see the opposite. You'll see the heat being extracted out. And obviously the sensor's working. So let's flip that around now. Let's just set and go high this time. Let's go to 40. And there you can see the outside starting to drop. This is now warming up and fully reassembled. Let's just double check from mains that it also works. And let's just set 0 temperature again. And we can see the mains is now pulling an extra ½ amp as well. This is cooling down. And we can see now it reckons it's around 1 degree. And the thermal camera says 2 degrees, so about the same. 2 degrees versus, oh yeah, 2 degrees now it's gone up to. So it seems accurate as well. So that does look like it's fixed. I'll get this one back to the customer.